problem 34 of Neetcode 150, median of two sorted array. So I would like to start by mentioning that this is a really hard problem. It is probably among the hardest one in the hard section. So um, I just want you to be aware of this. And with that being said, we can go ahead and start reading the problem. So we are going to be given two integers of arrays, num1 and num2. They are not necessarily going to be of the same size, but we do know that they will be sorted in ascending order. So this is great. And we will have to return the median among all the elements of the two arrays, and we are going to have to do this with the time complexity of log m plus n. All right, so let's go ahead and see the example that Neetcode is providing us. So we have nums1, which is basically an array containing 1 and 2, and we have nums2, which is an array containing 3. So if we add all these numbers together, we have 1, 2, and 3. And basically what a median is, if you forgot your high school maths, it's basically just the value where there is as many values to the left and as many values to the right. Right, so like 2 has one value to its left and one value to its right, so this is median. In the example 2, you will see an edge case or a harder case to understand where our nums1 is going to be composed of 1 and 3, and our nums2 is going to be composed of 2 and 4. So we're going to have, if we add both together, we're going to have an array of 1, 2, 3, and 4, and basically we want to take the two middle elements and find their average. So this is going to be 2.5. So this is how we find the median. All right. Okay, so how do we solve this? Because we can't really join them, because joining two array will result of a time complexity of big O n plus m, but we have to solve it in big O log of the minimum between n and m. So how? All right, so let's say that we are given these. Okay, so this is num1, this is num2, and let's just see them as there is a long one and there is a short one. Okay, so we will use a binary search, because binary search is probably the only way that we can actually have a time complexity of log of n. So we will use this on the shortest list of number. All right, so if we combine both here, for the first example, let's just remove the 10 to have a list with an odd number of values. All right, so I think that pretty much everybody can find just by a first hindsight that the median here it's actually the value 5. But how can our code do this, knowing that we have to be super efficient in time? So what we're gonna do basically, first we are gonna have to acknowledge that to the left and to the right, but let's just say to the left of our median, we have 4 entries. Okay, and this is super important, so we have to keep this in track so that we are 4. All right, and after this we are going to use our binary search on the short list. So by doing so, we will find that first the median, or the middle, let's just say the middle, is 4. So we are first going to say, hey, let's just take the left of that here. All right, and let's call it the first two numbers of that left side here. So we already have two numbers, so now we are going to have to pick two numbers of the long string. So let's take the long list. So let's take the first two numbers. So this is giving us the value of left side values that we are looking for, or 4 here. And what we are going to have to check is, basically if the value 3 here is is bigger than the value at the right of the the right value in the list or the array containing 2 and 4. All right, if this is the case, well, it means that we are gonna have if these here are left values, it will mean, let's say that for the sake of the example, this is actually 8. All right, so it will basically mean that we are gonna have like 1, 2, 4, 8. So this is our left values, and then we have a 7. So that will break the ascending order, right? I hope this makes sense. So this is what we are gonna have to check. So the 4 right values for each sub list has to be smaller than the value that is 1 units to the right. Okay, so 3 here is correct because 3 has to be equal or smaller than 7, and 4 has to be smaller or equal to 5, or this value here, which is great. Okay, so let's see another case where we don't have an odd amount of numbers. So this is where I am gonna add 10. All right, so the median here will be these two values added together divided by 2. So it will be their average, which is 5.5. Okay. All right. Hope this makes sense, because if you consider this itself as one value, well, it is the median. It is the median because you have now 4 values to the left and 4 values to the right. All right. But actually, how can we solve this in our problem? Once again, we're going to use our binary search on the short list, and this is going to be our middle element. Okay, so we are going to have this right here. All right, and once again, you see that we have 4 elements to the left of the middle, whatever that thing is. Either it is a combination or it is a single value. So we are going to keep our 4 here. So we are likewise going to add 2, the first 2 elements of the long list. And we are going to make our same check. Okay, so basically we have to make sure that 4 is smaller or equal than 5. And we have to make sure that 3 is smaller or equal than the value that goes after 4 in this list. And it is the case. And what we want to do after this is simply to take the maximum value of the top right element of both. So here we will take 4 and add it to the minimum value. And okay, I apologize for this confusion. I did made a mistake here. Basically, I wrote the wrong number as the left value of the median. It has to be a 5. I really apologize for this, and I will tell you why. Because basically, the left side, yes, the median is going to be equal to 5 and 6 average, but actually the left side is going to be equal to the length of the list. Here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's going to be this divided, or the length divided by 2, right? So it has to be 5. So I apologize for this, and this makes more sense because now we are going to take the first three elements here. Okay, and this makes this is how we are going to move forward. So there we go. These are like the the left side of the list. This is what we want to have. All right, so um, the same principle applies here. So we want to check if this value 5 here is smaller or equal than that value 7. And same here, we want to check if our 4 is smaller or equal than the value that comes after 5. It is 6, so yes. And then we are going to take the maximum value between the top right element and the right element of the right element of both lists. And this is going to be what we want to add in the average calculations. And after this, we also want to take the minimum value of both values that come right after the closing brackets, right? So in this case, it's going to be 6. So we are going to take the average of 6 and 5. And this is how we are going to return 5.5 as the average. So let's go ahead and start coding this. So first of all, we have to create our short and long. So let's call this short and long. And I will just say short L for short list and long L for long list. All right, so this short one, let's say that it is equal to our first entries. And then the long one is basically nums2. We are going to create our total. Let's call it total. And it is going to be equal to all the elements that we have. So basically the length of nums1 and length of nums2. All right. This is how we are gonna find the number of elements here at the top, or the left elements, and the amount of elements that we are gonna have to include in our left list. All right. So let's call this left side. All right, and the left side is going to be equal to total, and I'm going to use the integer division to round it towards 0. Okay, so now we have our initial setup almost completed, because we have to make sure that the short list is actually the shortest list. So we're going to say if the length of the long list, so if the length of the long list is smaller than the length of the short list, let's just say that the long list is equal to the short list and vice versa. So just like this. All right. And now we are good to go to start our binary search. So let's go ahead and write our start and ending index. So let's say start end, and the start is equal to always 0, and basically the length is going to be equal to the length of the shortest one, because we are taking the binary search upon the shortest string. All right, and now we are going to return our while loop. For this example, let me use a while through. So let's be lazy here. Inside our binary search, the first thing that we want to search for is actually the middle value of the short length. So we can call this mid, and this is going to be equal to start plus dn divided by 2, rounded towards 0. And we also have to take the amount of values, or like we have to find a way to get the index of like, for example, once we know that we have 2 and 4 in our left list, how do we actually know like the index of, like how do we get to know that we need the index 2 to have 5, right? So what we are currently doing, we know that we need 3 elements. So basically we take our 5 minus the length of this, okay? And the length of this is basically the index plus 1, because right, we are ending at the index I, which is index 1. So minus index, which is 1. We have to also do minus 1 to get the length. But this is going to give us 3, right, which is the length. But we have to reach the index 2 to get a 5, right? So we are going to have to decrease this by another 1. So it is basically going to be equal to 5 minus I minus 2. Okay. So I set the mid for the first the first value. Let's call it G to avoid any confusion. And this is going to be equal to our left side here that we created earlier on, minus I, or in this case we want to say mid, so minus the mid, and minus 2. And then we remember that the next check is basically to get to know if the value at the right, so this one is greater or equal, or is smaller than equal to the value here. So how do we actually code this? So I will first write s left, which will represent this, so short. So let's say that the value left at the left is 4 and the value at the right is 7. So left is going to be equal to 4. So s left is basically going to be equal to the short list at the index of the middle. But we have to be careful because they don't specify in the problem that they will never give us an array that has a length of 0. So in this case, it might gonna happen that we actually get a negative value after our first round of binary search. So we have to actually render the short length at the index of the middle only if basically if the middle is greater or equal than 0. And otherwise, we are going to be willing to render a very small value that will never be beaten, or that you're never going to get a value that is smaller than this one. So we are going to use the infinity value and the negative infinity. So float. Okay. So we did s left. How do we get s right, which stands for short right? Well, basically it's going to be the index mid plus 1. And also we have to make sure that we're not getting out of bound here. So how do we do this? We have to make sure that the next index is smaller than the length. Okay, so if mid plus 1 is less than the length of short L, and otherwise similarly to the uh, the s left, we want to make sure that this is something very huge that will never be added in the median in the calculations. Otherwise, we will get an infinite result. So we have to set that to float infinity. All right. And now we are gonna write our, I will say L for long, for a long list. So L left, it's gonna be equal to long L at the index G that we just created. And once again, the same logic applies here. So we have to make sure that G itself is always in the bounds, because there is a possibility that it will eventually reach a negative value. So we have to be accountable for that. So make sure that G is at least equal to 0, but it can also be greater. And then we have to create our L right, which is going to be equal to the long list. Once again, at the index G plus 1. And again, you have to make sure that G plus 1 is smaller than the length of the long list. Otherwise, set that to infinity. Okay, and now we are good to go, and we are jumping into the logic where we have to check if the L left is smaller or equal to the S right, and if the S left is smaller or equal than the L right. All right, so if this is the case, we have a winning combination. So if S left, okay, is smaller or equal than L right, and also if P left is smaller or equal than A right, or I use P, but basically if L, all right, got confused here. So if this is the case, all right, first we have to know if we have an array whose length is an odd number. If it is the case, we want to return a single value. Otherwise, we want to return the, as I mentioned, the maximum value of the two left values and the minimum values of the two right values. So we can do this by saying if, and then what do we want to do? We want to say if the total is divisible with the, so basically if it is not, if there is a reminder, we want to return the minimum value between the S right and the B right. All right, otherwise what do we do? Well, we are going to be willing to return the maximum value between the S left and the long left, and we want to add this to the minimum value of S right and L right, and we divide this by 2. All right, okay, so what if we don't get to that scenario? So what if the value, so let's say it like this, so what if the the value of the short string to the left is actually greater than the value of the B string to the right, or the long string to the right, pardon me. Um, so in this case, we'll use the binary search, and we will place our left pointers um, to 1 unit to the left of the current middle. Because basically we have to, if this is, let's say, a 3, I will just clean this up a little bit. So let's say that this is a 3. Well, we will be willing to shorten a little bit our array of left side values. All right, so we do so by moving our end pointers. So end pointers by 1 unit to the left of the middle, so mid -1. And the other case is basically that the value of the long string to the left is actually greater than the value of the right string to the right, the short string to the right, pardon me. So then we will go for the right side of the the array. So basically the start will be the mid +1. All right, so hopefully I didn't do any typos in all of this. Let's submit it. Okay, it seems like it is taking too long. I'll just refresh the page and see if it works. Okay. So, okay, we did a typo here. All right. We wrote should have written short L for short list. So let's see if this works. No. I wrote B right, which is actually L right, and boom, there you go. All right, so I hope you learned from this video, and I really hope to see you in the next one.